Well, it's really a pleasure to be here and talking about precision agriculture, and it's a great honor to follow Dean Fairchild, who, I had the pleasure of collaborating with a long time ago in the 1980s, and I'll talk a little bit about that. Precision agriculture, like Dean said, has been around for a while, and in reality, if you go back, even in the 1920s, there was research from the University of Illinois that really looked into how soils should be sampled in fields to make fertilizer recommendations. And a lot of that was just deemed to be too impractical to actually implement. But in the 1960s, some researchers at the University of Illinois, Melstead and Ted Peck, they, kind of revived that idea, and they started working on intensive soil sampling. And with the idea that, if you go back to a field year after year, you could identify where things are changing. And so there's a few diagrams here showing, maps created in 1961 for soil pH, and in 1994, after many, many years of applying lime and doing things to correct the pH problems, how those patterns changed. Similarly, out in Washington State, where I started my career in the 1980s, we had a couple people, Irv Dow and his colleague James, who were working along similar ideas. And they started thinking about the errors in actually taking a few samples from the field to make fertilizer recommendations, and thought there's a lot more variability that has to be managed, and you can make more accurate recommendations if you can do a good job of sampling. So they started doing intensive soil test projects, and here's some examples of their research out in Utah from the 1970s. We didn't have good mapping programs at that time, but you can see the size of the circle indicates the amount of soil test phosphorus or soil available phosphorus, and you can kind of, if you squint a little bit, you can say, okay, well, these probably areas that don't need too much fertilizer. These areas that have small circles need more fertilizer. And so, they came up with this concept of saying soil test variation is not random, and if you map it correctly, you can get some idea of where to spread fertilizer variably. And compositing samples is, again, something they really thought was a bad idea. So then getting back to what Dean was talking about, Pierre Robert at the University of Minnesota, working with Dean Fairchild and his colleagues at Central, these are really the beginnings of what we called then soil-specific crop management, farming by the foot, or things of that nature. We didn't have the term precision farming at that time. In 1982, Pierre defended his PhD dissertation, which was directed by Dr. Richard Rust, who's a soil pedologist in the Department of Soil Science, now the Department of Soil, Water, and Climate. And his dissertation was evaluation of some remote sensing techniques for soil and crop management. So he was building on those photos that Dean provided, which were color infrared photos, and he developed a farm information management system that contained information about, where the variability was located. And he said you could use that information to adjust seed density, herbicide rate, or fertilization according to the patterns that were being assessed using the color infrared photos. And here's a photograph of Pierre at that time showing the system on these really fancy, IBM computers that we used to have that had about, 5 kilobytes of RAM storage. So they're essentially useless for today's data that we have. 5 kilobytes isn't even one photo on your phone, right? But he's showing this to Jim Anderson, who was the soil scientist that worked with him on that project. All right, so independently of all that, I was out at Washington State at the time. I didn't know anything about Pierre Robert, but I was coming from Purdue University, where I did a PhD on, of all things, stochastic processes and molecular dynamics. And I used a supercomputer to try and track the trajectories of 250 water molecules near a clay particle. So it was really theoretical work. And when I got to Washington State as an assistant professor in soil physics, I said, well, I got to do something simpler than that, because nobody's going to care about 250 water molecules and where they're moving on the water, on the soil. So I looked out at the landscape, and anybody who's been to the Palouse region of Washington State knows it's a beautiful landscape. We have these rolling hills. Here's the topography for one site that we studied. And the tops of the hills are all eroded, and you have light-colored soils, and the bottoms are all really black, fertile soils, and they have very high productivity. And I said, why are we not looking at the spatial variability of these properties, like soil organic matter content and soil depth and soil color? And so I started, doing some sampling, and these were the transects that, we sampled on. We went out and we didn't have the GPS, so we figured out ingenious ways of finding out where we were in a field without using GPS. And we took samples every 15 meters, and we developed nitrogen and phosphorus recommendations. And then we tested them out by applying a variable strip and a uniform strip of nitrogen and phosphorus side by side. And I was working at that time with a person from Central named Max Hammond, and Max was also working with Dean Fairchild. So indirectly, we were all working together, and we published some papers on this research in fertilizer conferences in 1987 and 1988, where Max and myself and Dean were all co-authors of those papers. Based on this research, which was either in rain-fed wheat-grown area or irrigated potatoes, we came up with the idea of management zones. So the way that came about was we sampled the soils for different variables like phosphorus and potassium. And then there was no GIS. So I got the idea, let's create a matrix. Where's the low phosphorus and the low potassium? Where's the high phosphorus and the high potassium? Where's the low phosphorus and the high potassium? And we could grid it out into 9 categories. And then we needed a way to map that, and there was nobody who knew how to do that. I found a way to do that, and I created maps where you could reclassify all those 9 combinations into from 3 to 5 categories, which I called management zones. And then we created these maps, which are shown here. So you have one management zone here, which has low fertilizer rates, one management zone here, which has higher fertilizer rates, and this was an irrigated potato field. And we did the same in this other wheat field. So we published that work and defined management zones as areas which are relatively homogeneous within a larger field that differ from one another in fertilizer recommendations. And that concept, just took off. I mean, it took off. It's used now over, the whole world. Another thing, after, I actually was invited out to Minnesota during this research to license my technology to Soltech. Soltech wanted a way to create maps that they could put into the computer tractors that Dean was showing. And we used an EEPROM, a chip, to burn that map into the EEPROM and then display it on the screen that was in the tractor. And as the farmer drove along, the farmer could manually vary the rates of fertilizer as they crossed from one zone to another. So that was like the technology that was actually developed in Soltech, which relied on the concept of grid soil sampling and the reclassification of the information into decisions. So I got, familiar with Minnesota during that time. Later on, my colleague from the Washington State University, H.H. Cheng, took a position in Minnesota as the head of the Department of Soil Science. And later on, he recruited me to come out and join the University of Minnesota as an endowed chair position, and I worked very closely with Pierre after 1995. Now, in the meanwhile, Pierre and Bill Larson and Dick Rust organized the first so-called conference on precision farming, which was called Soil-Specific Crop Farming. And they invited me to come to that workshop in 1991. So I came out and talked about the research that I was doing, and that's where I met Pierre Robert. And before that, we hadn't known each other, but Pierre had heard about my research and invited me. So this workshop evolved into the international conferences on precision agriculture, which were held in Minnesota from 1994 to 2006. And I helped organize two of those conferences by myself in 2004 and 2006 after the death of Pierre Robert. And then I handed it off to Raj because I thought Raj was a really brilliant and up-and-coming person in the area of precision agriculture, and he could do a really good job, and he did a fabulous job in organizing a few other of those conferences and actually forming the International Society for Precision Agriculture. So he had a great role to play in a lot of this development. Anyway, Pierre and I established the first Precision Ag Center in the world in 1995 here at Minnesota because we were really doing the leading research at the time. Everybody looked to Minnesota for leadership on that topic. And you can see the book, the proceedings of the third international conference, which was held in 1996, sorry. Pierre also, founded the Precision Agriculture Journal in 2000, which is now the leading area where you can publish research on precision agriculture. And I was appointed as one of the founding associate editors, and I'm still an associate editor for that journal. Today it has an impact factor over 6. There's over 1,000 papers submitted to this journal every year. And so that just shows you the explosive growth that we've had. Now, this Precision Agriculture Center continues to exist today, and I've had to step down as the director of the Precision Ag Center because I'm leading another center for artificial intelligence, which takes up a lot of my time, and I can't do both of these. And so Yuxin Miao was selected as the successor, and he is now the director. And we have associate directors, Si Young and Vasudha Sharma, who are both here today. And we're very proud of this new leadership and the new ideas and the energy that they bring to precision agriculture. The Precision Agriculture Center has over 20 faculty members as affiliates from the College of Food, Agriculture, and Natural Resource Sciences. That's 4 departments, including soil, water, and climate, agronomy, bioproducts and biosystems engineering, and I think either applied economics or plant pathology. I can't remember. And entomology is also included there, but I've lost track of who's actually an official affiliate now. So it's anywhere from 4 to 7 departments. We also collaborate with the research and outreach centers at Waseca, Lamberton, and Crookston. We've mentored over 60 graduate students and postdocs over the years. Many of them are here in the room today. You have Jose Hernandez, who's a former PhD student who's doing wonderful things in industry. Overseas, we have, professors like Siva Balasundram, who's in Malaysia. We just have a lot of alumni who are from all over the world working on precision agriculture in various ways. We've been fortunate to get funding from federal agencies to support research in precision agriculture at the University of Minnesota, and very large grants. And that includes, today, the $20 million grant that we got from USDA NIFA for the Artificial Institute in Land, Economy, Agriculture, and Forestry, which wouldn't have happened without this collaboration from the precision agriculture that really formed relationships between CFANS and the College of Science and Engineering. So we work very closely with two departments in the College of Science and Engineering, Computer Science and Engineering and Mechanical Engineering. And those relationships have really blossomed. There have been a lot of other ways of support for the Precision Ag Center through legislative initiatives such as MnDrive and AGREET. And AGREET led to the hiring of, the three people that you see right here on this page. The Computer Science and Engineering Department has a Minnesota Robotics Institute, and the director of that institute, Nikos Papanikolaopoulos, and I have worked very closely together for the last 15 years or so, and he'll be here later this morning. So we have this strong history of collaboration and are very proud of what has been accomplished. We also collaborate very closely with agribusiness, and so there's hundreds of companies that have been formed because of precision agriculture. Local examples include, Earth Daily, Centera, which has now been bought out by John Deere, Centec, Earth Scout, who's here, has a table, Farmer's Edge, Jose was formerly with that company, and then Aglytics. We also have collaborations with Land O'Lakes, Winfield, and with CHS. So all of this has a large impact on jobs, the economy, and it's really just central to the agricultural economy of Minnesota and the US as well as the world. And our partners in these industries, have really written very glowing testimonies about the value of these collaborations. These collaborations lead directly to products that can be licensed and commercialized by these companies and can create jobs and boost our economy. So here, a couple of summary statements about what I think the Precision Ag Center has accomplished in terms of pioneering research, education, and extension. The collaborations, that were established continue to exist, and the impacts are really far-reaching and wide-ranging. And we really want to thank all the funders, all the people, the students, the collaborators, and all of the partners that have made this possible. Without those partnerships, none of this would have happened. Thank you very much.